Hi, so good morning, guys. Thank you for joining us today for our final presentation. So for the past 10 weeks, our team has been immersed in developing and testing a vehicular AI agent. And as we showcase our findings, we also want to highlight the collaborative spirit that has propelled our project forward. So let's take a moment to introduce the remarkable individuals that make up our team. So we have Haejin, myself, William, Donald, Romany, Vibodh, Aditya, and Eddie. So our main motivation is to explore interactions. So despite the benefits of autonomous vehicles, there are many challenges that that slowed the wide-scale deployment and adoption. And so in order to spread the potential benefits of autonomy, as well as cater to those who prefer to drive themselves, there's a need for intelligent interactions between increasingly automated vehicles and humans. So our two goals were to develop an AI agent that can interact and communicate with drivers in real time, as well as test the AI agent by creating realistic traffic simulations to replicate real-world traffic scenarios.
So for our backbone of our project was running experiments by driving cars. And obviously we can't do that outside because it's very dangerous. So that's where Carla comes in. Carla is an open source software where we can manipulate the environment by using Python and create cars and other vehicles and pedestrians and run experiments on and collect data. It allows us to collect sensor data and other data regarding collision, speed, and turn radius, and anything you can imagine. So Carla PazNet is the machine learning model our project worked on. PazNet is a previous model which took physiological data such as eye gaze and heart rate and other physiological factors to output whether it is a good time to interrupt a driver and tell them to do something or not, because part of having an AI agent is having a safe time to interact with the driver.
So these are examples of some sensor data we collected. In the upper left, you have your depth camera. In the upper right, instance segmentation. In the lower left, RGB camera data, and lower right, semantic segmentation.
Okay, so next up is the scenario runner. So scenario runner is a module that helps us define and execute traffic scenarios in the Carla simulator. So here's an example of a scenario in the scenario runner wherein the car has, and for the scenario to be successful, the car has to stop behind the stationary car, try passing it from the left, and then again come to a complete stop. Next slide, please. So yeah, Town 12. So Town 12 is one of the maps in the Carla simulator, and it is a vast map that spans about 100 square kilometers, which is significantly larger than the standard map. It also consists of various sections like highways, farmland, downtown area, and things like that. And definitely it's a good choice to have for larger experiments. However, we did find a few challenges while we were trying to work with the Town 12 map, which included a drastic drop in the frames per second. And obviously we did find ourselves running out of storage because Town 12 is something very heavy.
So something that we implemented into Carlo was the GPS map. So as you're driving through the road, it'd be good to see like what's happening around you in like in a map view. So we turn this into a map, like you have a Google Maps on your phone. So we turn this one into that. Next slide, please. So here you could see this is like a little demo of us running it. This is Eddie driving the simulation. Over here you could see him driving, and that's the view that you'll be seeing. And on the left, you see the map, and we made it a little navigation. So as you're driving through the specific scenario, it tells you what the directions to move forward with. It's right here. Just look at the screen. Go down, go down. And just listen closely for the voice. We also integrated a voice agent into the model, into the simulation. So as you're driving through, if it detects a like any obstacle in front of you, it'll give you a warning.
So now that we had all these things working together, we were ready to collect some data and see what we could find. So the question that we had is, how do we determine if something is a good run or not? So when we, in other words, if we were looking at someone's run of a scenario, how do we determine how well it went? So we've used 5 different types of data that we can collect using Carla, which is braking, steering, speed, collision, and lane invasion data in order to determine that. So we also did a perfect run ourselves, which was us trying to get as close as possible to the ideal run of a scenario so that we can compare it to the runs that people did who didn't know the scenario ahead of time. And we collected data from 2 different types of like groups that we've made, which is one that used the voice agent and one that didn't use the voice agent. So as you can see here, these are some examples of results that we got. So over to the left, this was the data we collected for our perfect run. And while we don't have the collision and lane invasion data showing there were none of them in our perfect run. Here you can see that this is the data we got from the run that was done without the voice agent. And if you see here, there was a collision that happened right around the middle, which was the collision with the cyclist. And, and up here, this is the data we got with someone that used the voice agent. And you can see here, there are no collisions present. And while we haven't collected nearly enough data to make any concrete conclusions, I think this is the start of an interesting, this is some interesting data that we can explore further.
So for our future plans, as previously stated, Town 12 is a great resource for more complex scenarios, but we're limited in hardware right now. In the future, we want to look into building more complex scenarios that use its larger routes and its more realistic urban driving situations. Next is collecting more data with our scenarios to train the AI agent, Carla PazNet. So we would all like to thank the staff and faculty at WINLAB for providing us this great experience and opportunity, and thank our advisor, Naveed, and mentor, Professor Ortiz.